Section formula for vectors. In this module, you will learn about section formula for vectors. Consider a directed line segment PQ. Let position vector of point P be vector A and position vector of point Q be vector B. Suppose point R divides the line segment PQ internally in the ratio m:n. The position vector of this point R is vector R. Now, look at triangle ORQ. Applying triangle law of vector addition, we get vector B as the sum of the vectors R and RQ, which implies that vector RQ is equal to vector B minus vector R. Similarly, in triangle OPR, we get vector PR is equal to vector R minus vector A. Since point R divides vector PQ internally in the ratio n:n, n into vector RQ is equal to n into vector PR. By substituting vector B minus vector R for vector RQ and vector R minus vector A for vector PR, you get this equation. Solving this, you get the position vector of point R, that is vector R as n into vector B plus n into vector A upon m plus n. If point R is the midpoint of vector PQ, then m becomes equal to n, and so you get the position vector of point R as vector A plus vector B upon 2. Now suppose this point R divides the line segment joining the points P and Q externally in the ratio m:n. In the triangle ORQ, applying triangle law of vector addition, we get vector R is equal to the sum of the vectors B and QR, which further implies vector QR is equal to vector R minus vector B. Also, in triangle OPQ, applying the triangle law, we get vector PQ is equal to vector B minus vector A. Since point R divides PQ externally in the ratio n:n, n into vector PR is equal to m into vector QR. By substituting vector R minus vector P for vector QR and vector R minus vector A for vector PR, you get this equation. Solving this equation, you get the position vector of point R, that is vector R as n into vector B minus n into vector A upon m minus n. In this module, you have learnt that the position vector of a point R that divides the line segment joining the points P and Q with position vectors A and B respectively internally in the ratio m:n is given by m into vector B plus n into vector A upon m plus n. If R is the midpoint of the line segment, joining the points P and Q with position vectors A and B respectively, then the position vector of this point is given by vector A plus vector B upon 2, the position vector of a point R that divides a line segment joining the points P and Q with position vectors A and B respectively externally in the ratio m:n is given by m into vector B minus n into vector A upon m minus n.